So basically, in biostatistics, we look at two major branches. The first being the inferential statistics, and then the other being descriptive statistics. So we are going to look at descriptive statistics and what they really mean. So that is going to be our area of discussion. So when we talk about descriptive statistics, we basically look at how we can summarize or even describe a data set that has been given to us. So, for example, you can have a class of, let us say, a class of 10 students. Okay, you have a class of 10 students, and then you give them a test, and they have different scores. We can get 60, 70, 80, 90. Okay. But when you have a list of these students with their marks, you may not really get to understand how they really performed, because you're not looking, you don't have concrete figures to really describe or even summarize your that data that you have. If you're basically calling a data set. So using descriptive statistics, you can get insights. Okay, you can get insights about a data set that you have. So that the descriptive statistics help us to summarize and even describe data sets, so that we can easily understand it and make good conclusions about a data set. So we have uh, two major uh, measures of describing the statistics broadly. So we have the measures of central tendency, and then we have what we call the measures of uh, variability. Those are the two broad measures that we have. So each one of these actually, they have their own different measures. So let's just start with the measures of central tendency. With measures of central tendency, we want to see uh, the different data points. How are they closer to the center? Oh, we have just said looking at the average of the data set, and we look at three major measures: the median, the mode, and then the mean. So let us start by looking at the mean. The mean is what we have often call the arithmetic. The mean is basically what we often call the arithmetic median or the average. Okay, the average can be looked at as the sum of all the values divided by the number of values. So if you have 10 students who sat for a test, you get their marks, you add them divided by the number of students. So you get the average score or the mean score. You can use that as a way of summarizing data if the data set is symmetrical in distribution. What we mean symmetrical in distribution is that the data should not be skewed, meaning that you should not, the data should tend towards what you call normal distribution, which is usually a bell-shaped curve. If you can check that out, normal distribution is a bell-shaped curve. Issues to do with the intelligence, height, these ones usually follow the normal distribution. So it is usually a symmetrical distribution. If you have data set that is like that, then you can use the mean. Why? Because if you have what you call outliers, then you're going to have skewed results in terms of your mean. For example, if you have the 10 students, majority of them have B's and A's. So they have 80s, they have 70s, they have 75, 85, 90. And then there is this one student who has got 15%. Now, when you add the marks and then divide by the number of students, the average is going to be low, or the mean is going to be low, because of this student who got 15. So it is going to lower the average, and that 15% is what we call the outlier. So the outlier can distort the mean considerably, and that is what we call skewing. It will skew the results. So that's the disadvantage of the mean, is that it is very sensitive to extreme values. Similarly, if you get most of the students scoring your party, and then you get another one who gets, let us say, 95, and then when you add, you will see that the average will a little bit increase, but that is not really giving us very good information about the data set. The other example is when you say that the average salary for my staff is, better say, $600. Okay? When you have that average, it sounds like, okay, now that is not bad. $600 every month, that is not bad. But then when you look at how much each individual is getting, you realize that actually the MD, the managing director, is getting £20,000, and then the rest of the staff are getting below $400. But when you have that big value plus these small ones, you get the average of above $600 or $700. Okay, so that is the disadvantage, is that the mean may actually not portray the reality. So the next measure is what called the median, which is the middle value after you arranging the data set in either ascending or descending order. Okay, it is also very useful if you have outliers. At least call it has that advantage that it is not very sensitive when you have outliers. But the challenge is it does not really consider the actual values on either side. Just looks at which figure is in the middle. So that is the disadvantage it has. And then the last one of the measures of central tendency is the mode, which is basically the number, the figure or the value that appears most times in the data set. So which one has the highest frequency? It is very good to use when you have what you call categorical data or discrete data. The challenge is that sometimes you can have data set, and that data set does not have the most appearing number of value. So that is the potential weakness you can have there. So let's look at one example of how you can really do the calculations for mean, median, and mode. So the mean you add and then divide by the number of times or the number of elements in there. So we have measurements of blood pressure, systolic blood pressure, really in millimeters of mercury. Okay, so with that data set, you can calculate in the mean, which is the sum of the different systolic blood pressures divided by the number of times that this systolic blood pressure have been taken. So in this case, it is actually 10. So we divide the sum over the number of values, which is 10, and then you get 120 and 125 millimeters of mercury as your main systolic blood pressure. And then we have to the median, which you can actually arrange the systolic blood pressures from the lowest to the highest. The one which is in the middle forms the systolic, forms the media. And in this case, it is 120, which is actually in the middle. And then the mode, which is basically the number which appears most times. And I think in this data set, we do not have a number which is appearing most times. So do we have one here? I think there is one here. 120, 125. 125 is the number which is appearing at least 2 times. But there is also 120 which is appearing thrice. Okay, so there is no value actually. There is no value that appears more than that.